Hello and welcome to the feedback video for assignment 5 circular motion. In this video we're going to look at the questions indicated here, and at the end of this video you'll be asked to complete a question that includes some similar concepts. Please pause the video, attempt the questions and hand them back to your teacher as soon as possible. The first question is testing your basic knowledge of circular motion. For any object moving in a circular path, regardless if the speed is constant or not, a force is required towards the centre of curvature. Remember back to basic principles of forces. A force can change the speed, direction, or shape of an object. Velocity is a vector property with a linear direction, shown here with the grey arrows. As the car moves in a circular path, its linear direction is changing due to the resultant or centripetal force acting on the car towards the centre of curvature. Now, as velocity is a vector quantity with both magnitude and direction, although this magnitude of velocity or speed is constant, the direction is not. It is changing. With this in mind, the velocity is therefore changing, and this is our definition of acceleration, the rate of change of velocity. We can therefore say that the car is accelerating towards the centre of curvature, as acceleration is always in the direction of the resultant force, in this case the centripetal force. As for what provides this force, it would be the friction between the car tyres and the road surface. The second question wants you to calculate the magnitude of this force if the car has a constant speed of 14 meters per second around the corner, with a radius of curvature of 15 meters. Under the diagram it also gives us the combined weight of both Scott and the car. The first step in answering this problem is to identify and list the variables, and then identify the correct equation that links them. This gives us a slight problem, as it gives us weight but not mass, so there is an extra step here to calculate the mass from the given weight, so we can substitute it into our centripetal force equation. Weight is just mass multiplied by the force at which gravity pulls on each kilogram of an object with, which is a constant and is 9.8 newtons per kilogram. After dividing both sides by g and cancelling the original g that was being multiplied by mass, I now have mass as the subject and can substitute my values into the equation and get a mass of 1,200 kilograms. I now have all the suitable variables to substitute into the centripetal force equation to get an answer of 15,680 newtons. However, the question asked us to use an appropriate number of significant figures. Looking at the variables, our least accurate piece of data was to 2 significant figures, so our final answer should also be to 2 significant figures. This would round up our answer to 16,000 newtons. The third question is another common circular motion question, asking us to explain the effect of water or ice on a car's motion as it tries to go around a corner. You might know what is going to happen, but it is a skill to be able to explain this scientifically. Firstly, we should identify what effect of water on the track is going to be, and that is that it will reduce the friction. This is what provides the centripetal force that allows the car to turn, so a reduction in friction will mean a reduction in the centripetal force. If we imagine the car moving around the corner on a dry track at 14 meters per second. As the track is dry, the tyres can get the required friction to provide the centripetal force. On a wet track, if the car tried to complete the same corner at the same speed as before, it would require the same size centripetal force. However, there is less friction, and therefore the car is less likely to be able to make the turn. So friction in the wet conditions is less likely to be able to provide the required 16,000 newtons, and therefore the car would slip. If Scott reduced his speed then a smaller centripetal force would be needed, and it would be more likely that he could get this smaller force from the friction between his tyres and the road. If we approach this mathematically, you should be able to see from the centripetal force equation that centripetal force is proportional to velocity squared. Therefore, as you reduce the centripetal force, you must reduce velocity, or the magnitude of velocity, which is speed. Right, okay, so if you could please pause the video, complete the question, and hand it back to your teacher as soon as possible.